Hello, this is Mr. Collier, and today we're going to do some problem solving with Venn diagrams. Okay, so in the following example, we've got students who own DVD players, Blu-ray players, and then we have in the intersection here we have people who own DVD players and Blu-ray players, and then there's two people who don't own either. Okay, so determine the number of students who were surveyed. So to figure that out, we'll have to add up all of these numbers together. So 2 plus 8 is 10, 22, 26, so 26 total people were surveyed. Who has a number of students who have a Blu-ray player. So we can just add up all these numbers in the Blu-ray section, which is 12. So 12 people have a Blu-ray player. How many people have both DVD player and Blu-ray? Well, that would be this one right here, 8. Number of students who have at least one type of player. At least one, that's actually D union B. Okay, so they have a DVD player or a Blu-ray player. So we just add up all the numbers here inside both these circles, and that gives you 24. The previous one was the intersection, right? And number of people who do not have any sort of player, that would be, let me write this as D union B and the complement of that. Okay, so that's everything that's not in D or B, so basic people who do not have a DVD player or Blu-ray player is 2. Alright, and let me just write the others in set notation as well. So the number of Blu-ray equals 12, and I guess the number in the universal set is 26. Alright, next example, or actually right here, next example. The passengers on a bus were questioned about the newspapers they bought each day. 3 bought both a morning and evening, 15 bought a morning, 8 bought an evening newspaper, 8 did not buy at all. Okay, so we have morning and evening. Let's put these numbers in. 3 bought both. Now 15 bought a morning newspaper. So 15 bought a morning newspaper, but 3 bought both. Then you put a 12 in here, thus 12 had just the morning newspaper. And 8 bought an evening newspaper. 3 bought both, so 5 more people bought just evening newspaper. And 8 didn't buy anything at all, so 8 would be outside these two circles, but still within the universal set, right? Show this information in Venn diagram. How many passengers were there on the bus? So that is the total number of people here, which is 28. How many passengers bought a newspaper at some time in the day? So that's actually the number of people who bought morning, union, evening. So that's basically, we just add up all these. Let me shade that. We add up the morning, union, evening, and we get 20. So 20 people bought a newspaper at some point in time. Okay, next example, we have 32 students, 21 study music, 14 study art, 5 students do not study either. So let's set that up now. Try to draw a nice Venn diagram. And we have 5 study neither, so 5 is going to be out here. Let's call this music and this art. And what we don't know is we don't know the intersection here, right? But we do have 32 students, and there's 5 that don't study either. So that's 27 students. Both these, the music and the art, should add up to 27. Alright? Both of those should have 27. Now what happens if I put in 21 and 14 here and assume there's no intersection? What happens then is we have 21 plus 14 equals 35, which is way too much, right? We need 27 students in here. So, but the difference between those two is 8, right? We've counted 8 too many students. So what I do is I'm going to put in 8 for the intersection here. I put in 8 for the intersection. And then let's see if this works out. So there's 8 that study music and art. Then there's 6 more that study art. And 21 minus 8 is 13 that study music. Let's see if this adds up. So 6 plus 18 is 14, plus 13 is 27, so that works. And then plus the 5 gives me 32 original, so that all works out. Alright, so the next example, we have 24 grade 10 students. It says 10 are on the swim team, 9 on the football team, 9 on the volleyball team. So I'm going to write S, F, and V for swim team, football team, volleyball team. It says 4 are in both the swim team and football team, 4 play football and volleyball, and 3 are in the swim team and volleyball team. One person plays all 3 sports. So actually I like to start right there and work our way backwards here, because if one person plays all 3 sports, they're in that triple intersection part right there, so that's that one person. And then I'll work backwards and we'll be able to figure out all the other numbers. 3 are in the swim team and the volleyball team. So that's swim team, volleyball team. 3 are in the swim team and volleyball team. So that would be this region. Should add up to 3. But we have 1 here already, so there should be 2 in this region. Then we have 4 people play football and volleyball. So this whole region should be 4. So this has got to be a 3. 4 people swim on the swim team and football team. So this should be 4 altogether. So that needs to be a 3. And now we figure out these other regions using the totals. So 10 are on the swim team. So we have 6 here already, so 4 people just are only on the swim team. 9 people total on the football team. This is 7, so there's going to be 3 who are only on the football team. And there's 9 volleyball players, so that's 6, so there's going to be 4 more here. Okay, now if we add up all these numbers, we get 20. There's 24 total students, so there should be 4 who are not playing any of those sports. Okay, now we can go ahead and answer the questions. Find the number of people who play volleyball or football. So the number of people playing volleyball or football is, so we just add up all these numbers, volleyball or football. So add them up, I get 10 here, plus 6 is 16. Okay, so the number of players who are only on the swim team, that would be this region right here, that's 4. And the number of players who are not on any of the teams, well, that's going to be 4 as well.